The Pradhan Mantri Awas Yojana Urban and Pradhan Mantri Awas Yojana Gramin have been initiated for urban and rural areas respectively by the Union Government, with a mission to fulfill the dream of the Honorable Prime Minister of India to provide a decent 2-room Pakka house with electricity, water and toilet facility to every household of the country by 2022, the 75th year of independence of the country. This challenging task requires an integrated approach to deal not only with land, finance, regulatory mechanism, but also use of appropriate building materials and construction practices so as to ensure fast-track delivery of affordable, quality and durable houses. A number of alternate construction techniques and practices showing potential for mass housing construction, evaluated and recommended by Building Materials and Technology Promotion Council, are being used in construction of houses in different parts of the country. Monolithic concrete construction using modular formwork system. One such technology is monolithic reinforced concrete construction using modular aluminium composite formwork system. Originated from Malaysia as Mivan Formwork, it is now being manufactured in the country and also imported by many agencies in the country. Aluminium formwork is the most widely used formwork system globally for a wide range of construction practices. The system is used for forming cast-in-place monolithic reinforced concrete structure of high-quality standards with rapid construction cycles. The system enables one to cast walls, beams, columns, stairs and deck of concrete home in one continuous pour. The windows and door openings are cast in place simultaneously with the walls and ceilings. MEP services can be placed into the walls before pouring of concrete, preventing the need of additional framing in the interior of the building. The structure is designed as RC load-bearing shear walls and slabs. Monolithic casting of slabs along with RC walls results in box-type structure, which is very strong and resisting horizontal forces due to wind and earthquakes. The engineered formwork system is designed based on the drawing of this structure and manufactured in the factory. While transporting, all panels are clearly labeled for easy identification on site and smooth fitting using formwork modulation drawing. The basic components used are panel, extruded aluminium or composite raid section, welded aluminium composite sheet made of high-strength aluminium alloys with 4 mm thick skin plate and 6 mm thick ribbing behind to stiffen the panels. Beam components: prop head beam, side panel, soffit panel beam, soffit bulk head deck components, deck panel, deck prop, prop length, deck mid beam, soffit length. Other components are internal soffit corner and external soffit corner. It works on rapid construction cycle with production line process approach. Typically 4 to 5 days per floor is the build cycle achieved. In case of double or single story house, build cycle is sometime 1 house per day. Day 1. Erection of vertical reinforcement and one side of vertical formwork for the entire floor. Day 2. Erection of second side of the vertical formwork and formwork of the floor. Day 3. Fixing reinforcement bars for floors and slabs and casting of walls and slabs. Day 4. Removal of vertical formwork panels, leaving the props after 24 hours and moving to another floor. Advantages of engineered formwork system: specially designed to allow rapid construction of all types of architectural layout. For same built-up area, more carpet area is achieved compared to conventional brick masonry. Since the entire structure is closed in and protected from weather, interior finishing moves ahead without getting affected due to weather condition. Erection does not require highly skilled laborers when forms and strip walls are complete and ready for treatment. With proper use, more numbers of repetition possible. It is recyclable after use. Scrap value is also high. Less debris generated. Overall embodied energy in monolithic concrete structure has been found to be lower than the conventional brick masonry. Limitations of engineered formwork system: requires uniform planning as well as uniform elevation to be cost effective. Lead time of about 3 months required to initiate the construction. Capital cost is high and need to be planned in advance for smooth progress of work. Curing requirement increases. If only OPC is used, due to box-type construction, shrinkage cracks will be more. Post-construction modification not possible. Large volume of work needed to be cost-effective. Larger the repetition, cheaper is the cost. The Formwork system has emerged as one of the accepted emerging technology for mass housing. In spite of some limitations, which can be overcome easily with proper planning, this construction system brings speed, quality and durability and economy in construction. Such systems are key to meeting the demand for efficient, sustainable mass housing. Prefabricated concrete construction. Precast or prefabricated concrete construction, as is popularly known, includes those buildings where the majority of structural components are standardized and produced in controlled environment at a factory or manufacturing site in a location away from the proposed building and then transported to the site for assembly. Originally developed in countries of Northern Europe, precast construction is one of the world's most common and resource-efficient way to construct a building. Various types of prefabricated systems, method of construction of buildings in certain order and discipline, have been used after Second World War in Eastern European and former Soviet Union republics. With massive plan of building houses in a short span of time amongst various options available, precast prefabricated concrete construction systems is seen to be a viable time-tested alternative. 4 different types of precast prefabricated concrete construction systems have been used for mass housing in the country now. The industrialized RC frame systems with walling elements. Precast RCC framing elements such as columns, beams and stairs are used to form the framed structure. The reinforced precast solid slabs for floors and roofs may be of normal weight or lightweight concrete. The main framing elements, that is columns, beams and slabs, are partially precast for about 60 to 75% of their overall final cross sections to facilitate wet jointing for intended structural integrity. Other RCC precast elements such as shear walls, lift shafts, service ducts are integrated into the frame skeleton depending upon seismic design demand, height and configuration of the structure. The frame structure, once erected, does not look different than any other concrete structure. Precast large panel system. It is large wall and floor panels connected in the vertical and horizontal directions so as to enclose appropriate spaces for rooms within a building. Horizontal floor and roof panels span either as one-way or two-way slabs. When joined together, horizontal elements act as diaphragms that transfer lateral loads to walls. Waffelcrete system. Structural ribbed load-bearing panels of reinforced precast concrete are bolted together. The joints between the panels are then caulked to form the walls, floors and pitched or flat roof building. Mixed system. In this pre-stressed hollow core slabs are used as roofing and precast elements for walling. The design concept of the precast prefabricated concrete buildings is based on buildability, economy, safety and standardization of precast components. Prefabricated buildings are designed with proper structural integrity to avoid situations where damage to small areas of a structure or failure of single elements may lead to collapse of major parts of the structure. Prefabricated concrete construction brings more resource efficiency and flexibility compared to cast in-situ construction. Controlled environment ensuring quality in production. Environment friendliness by reduction of wastes. Possible uses of industrial wastes in concrete and reduction in use of water and cement. Safer and healthier environment. Reduction in dust and noise pollution at construction site. Ease of working in all weather condition. Structural efficiency. Quality and durability in structure. Speed in construction, ensuring faster delivery. Overall economy. Success of prefabricated system depends on effective utilization of spaces, straight and simple walling system, limited sizes and numbers of components, limited openings in bearing walls, regulated locations of partitions, standardized service and stair units, limited sizes of doors and window with regulated positions, structural clarity and efficiency, ease of manufacturing, storing and transportation, speed and ease of erection and simple and effective joining system. CPWD has already adopted prefabricated concrete construction systems and is using them in their projects. Indian standard also gives provisions for design and erections of buildings using prefabricated concreted. National Building Code 2016 also covers provisions of different prefab systems for construction of buildings. The keys to successful implementation lie in the careful planning and understanding of the close relationship between design, construction, detailing, execution and manufacturing of precast components. With backing of performance evaluations by BMTPC, National Standards and National Building Code, CPWD Schedule of Rates and related guidelines, and a number of successful projects in the country, prefabricated concrete construction provides a very good option for the housing agencies in the country to construct quality and durable house in a fast-track manner to fulfill the requirement of providing shelter to all. Light gauge steel structures. Light gauge steel sections are formed in cold state from galvanized steel sections of thickness, usually ranging from 1 mm to 3 mm. Galvanizing of the performed coil provides satisfactory protection against corrosion in extreme environments. It is a well-established technology for residential construction in North America, Australia and Japan, and is now gaining ground in India because of its versatility and suitability for range of lighter load-bearing applications. The system is based on erection of a base structure by assembly of factory-made cold-formed galvanized light gauge steel sections and subsequently fixing of paneling materials to form walls and floors with and without insulating materials. Once designed as per relevant Indian IS 801 or International Codes BS 5950, the required sections of stud, C-sections with knockouts, dimplings, slots, service holes etc. as vertical members and U-shaped tracks as horizontal members are cold-formed in centrally numerical control CNC automatic pinnacle roll forming machines with production speed of 300 to 450 mH with very high precision. Once out of the machine, the sections are properly numbered, stacked and transported to the construction site as a package. Foundation for lightweight steel framing are essentially the same as for any form of construction, although dead weight applied will be much lower compared to conventional construction of brick masonry and RCC. Hence, heavy foundation may not be required. Sequence of construction is foundation laying, fixing of tracks, fixing of wall panels with bracings as required, fixing of roof panels, decking sheet, fixing of electrical and plumbing services, and finally fixing of walling materials and finishing of roofs with insulation. Profiles are assembled by trained team at the construction site in line with architectural plan. Special self-driven tapping screws and fasteners are used for joining different members. Walls are either made fixing in fill of type A cement fiber board conforming to IS 14862 in combination with gypsum board conforming to IS 2095 Part 1 or fixing precast concrete panels and filling with lightweight concrete, mineral wool, rock wool in the gap between the two panels. High-density polystyrene core plastered on both sides using wire mesh may also be used. There could be other options for infills also depending upon the requirements. With very high precision of production of the structural sections made of galvanized sheet and other components also of appropriate high grade, The well-designed structure made using this system brings durability and quality in construction. With pre-engineered steel sections which can be fully recycled, it is environment-friendly and brings speed in construction with overall economy. CPWD has also adopted this technology and incorporated analysis of rates for LGS in Delhi Schedule of Rates. EPS-based panel system. EPS-based panel system. The EPS technology is in use in many countries under different forms and brand names. The system is basically based on factory-made composite panel consisting of combination of self-extinguishing polystyrene corrugated plain sheet of minimum density 15 kilograms per cube meter and required thickness, sandwiched between two layers of engineered sheet of high-strength galvanized cold steel wire mesh interconnected to each other with high-strength steel connectors. The main function of the core is to provide thermal and sound insulation, and its thickness and type depend on its thermal resistance and design temperature. The truss formed with the galvanized wires gives the desired structural strength to the panel. The EPS panels are manufactured in different types depending upon the application. The key components of a building arrive on-site packaged according to size and construction sequence. The building site is prepared and a strip or rough foundation as needed put in place. The walls are vertically connected to the concrete structure and to the floor of the upper level by means of deformed steel dowels. The erection of walls are completed by strengthening each joint and corner and openings with additional wire mesh. The roof panels are secured to the walls using special steel sections, fixings and fasteners. Provisions for doors and window openings are pre-cut to fix the required door and window frames. Plumbing and electrical services are fixed through the depressions created in polystyrene core using blowtorch. The structure is finished on site by pouring or spraying concrete of appropriate grade and thickness to realize the different structural elements like walls, slabs and floors. The innovation lies in panels manufactured in a controlled environment in a factory setup with very high strength to weight ratio, attracting very low seismic forces, which are easy to erect at site with minimum workforce. It fulfills requirements of strength, durability and energy efficiency. When it's finished, a structure constructed using EPS panel-based technology looks solid as in conventional construction. EPS concrete wall panel buildings are environment-friendly and aesthetically appealing, a system that meets the needs of designers and resolves the difficulties of construction companies. They can be constructed quickly, resulting in tremendous savings in time and money. Research indicates that the materials themselves have a life expectancy of at least 50 years. From an architectural perspective, these homes offer a high degree of flexibility in floor plan design and aesthetic treatment. EPS panel have many advantages: reduction in construction time, lightness, handling and transportability, seismic resistance, cyclone resistance, integration with other systems, fire resistance, thermal insulation and sound insulation, saving in electricity consumption, saving in foundation cost due to reduced structural weight. Stay-in-place formwork systems. Many new formwork systems have been developed, amongst which stay-in-place formwork systems have many advantages. After concrete pouring and hardening, This type of formwork systems remain in place as an integral part of the structure and contribute to the structural integrity, durability, and even aesthetics of concrete elements. 3 different stay-in-place formwork systems evaluated and recommended by the Building Material and Technology Promotion Council for mass housing include Coffor System, expanded polystyrene, double wall system, and insulated EPS interlocking blocks concrete formwork. Coffor System. The formwork is composed of 2 filtering grids comprising of rib meshes made of galvanized plain steel GP sheets with herringbone mesh pattern rib lath, reinforced by C-profile GP sheet vertical stiffener. These grids are further connected by articulated horizontal MS rebar loops in one direction and cold-rolled close-annealed plate GP horizontal connectors in other directions. After the erection of formwork panels in alignment over strip foundation, closing of corners, edges of doors and windows frames, rebar positioning, concrete of required grade is poured inside the panels, either using pump, bucket or with shovel loader. The inside and outside walls are finished with cement plaster of suitable grade. EPS double wall system. It is an insulating shuttering kit made in factory for whole building based on 3-dimensional lattice made of high-tensile galvanized steel wires. At the exterior side of the lattice, high-density fire-resistant grade of expanded polystyrene panels are inserted, which transforms the lattice into closed structure that can be filled with concrete. Other materials like mineral board can also be used depending upon the requirement and cost economy. The steel wire also acts as armature and anchoring for the finished materials, and it holds reinforcement bars in place during concreting. The panels are erected on foundation using dowel bars and exterior surface is finished with cement plaster of appropriate grade. EPS-based stay-in-place formwork system has high heat-resistant property and brings down energy consumption required during winter and summer for heating and cooling. Insulated concrete forms, an American initiative, is used in Europe, America, Africa, and Southeast Asia. Insulated concrete forms ICF system comprises a panel of 2 walls of self-extinguishing expanded polystyrene EPS of density 24 kilograms per cube meter, separated by a nominal distance of 150 mm by hard plastic ties. The forms are open-ended, hollow polystyrene blocks which fit tightly together to form a shuttering system. These are assembled at site to hold reinforced concrete. The concrete of desired grade is poured into the hollow space to form a continuous wall. When hardened, the wall supports the structural loads from floors and roofs, and shuttering provides thermal insulation. Reinforcement as required from the design are also placed. Upper and lower surfaces of the polystyrene panels are castellated, and the vertical mating surface are tongue and grooved to form a tight fit when joined together. The rigid form does not require supporting falsework. Stay-in formwork systems are quicker, requiring less manpower and machines. These are used to form load-bearing walls, eliminating need for columns and beams. With the use of stay-in-place formwork, need for separate formwork is eliminated. It brings overall economy and speed in construction. The structure associated with these formwork systems are of reinforced concrete, which can be designed suitably to achieve desired strength and durability, making it safer even after natural hazards, such as earthquakes, with lesser maintenance cost. With revolutionary change in formwork system, stay-in-place formwork systems have potential to replace conventional formwork system and can be tried by housing agencies in the country to build affordable, safe, durable and sustainable dwelling units to achieve the overall goal of housing for all in the country. BMTPC, under Performance Appraisal Certification Schemes, has evaluated these systems in different forms and issued performance appraisal certificates to various agencies. With more and more construction agencies getting equipped with the manufacturing capability and developing their trained design and construction teams, the field is open for a healthy competition for the state government and other agencies to adopt these viable technology for their projects.